Hello everyone, today I'm going to talk about something about our assignment 2. There are 3 questions in assignment 2. So let's look at the first question. This question is about the confidence interval. We need to know how to get and construct the confidence interval when we have some unknown parameters. And the part A is about unknown parameter mu, and the part B is about unknown parameter delta square. So, in this question, we need to know the parameter estimation, properties of the normal distribution, and how to derive the confidence interval. Before doing this question, I need to tell you the steps to derive the confidence interval. We need to follow these 6 steps. The first step is determining the estimator. For example, we need to find the appropriate estimator for the unknown parameter. And the step 2 is to identify the sampling distribution, and most of them are follows the normal distribution. And thirdly, we need to select the confidence level, like 19%, 95%, or something else. And the step 4 is to find the critical value, and then we need to calculate the margin of error. After doing these 5 steps, we can construct the confidence interval. Okay, let's make the application. So the first part A, because the unknown parameter is mu, so we select the x bar to be the estimator to mu. And we know that x follows the normal distribution, but we need something follow standard normal distribution. So we can transform the normal distribution to standard normal distribution by the formula on the left, on the right. And after that, we can construct the confidence interval. First, we need to select the confidence level. We need the confidence level is 96%, and then we choose the critical value z sub alpha over 2. And by doing this, we can get the inequalities about z, and after transform they to mu, we get the inequality of mu. But what we want is not just mu. We want theta. Theta is the formula of mu, and we also found that this formula is increasing, so we can apply this formula to the lower bound and the upper bound in this inequality. After that, we got the inequality of theta. This is what we want, and this is the confidence interval of theta. So after knowing how to do this in part A, I think part B is we already know the steps, but this is a little different from the part A because the unknown parameter is changed. In this part, we need to use some properties of sample variance, because the unknown parameter is delta square, so we choose s squared to be the estimator of delta square. And also we can transform the normal distribution to standard normal distribution, and we use the relationship between normal distribution and the chi-square distribution to get the distribution of x bar and to get the mean and variance of x bar. And after that, we can also find the mean and the variance of s squared. And after that, we find that what we need is not just x squared. What we need is ln delta. Ln delta can be get from ln delta squared, that is ln s squared. So we need to use delta method to apply the formula to s squared to get the mean and variance of ln delta squared. Knowing the mean and variance of ln delta squared, we find that the ln delta squared follows normal distribution, and then we can transform this normal distribution to standard normal distribution, and after selecting the confidence level and critical value, and we can get the inequalities about ln delta, which is theta. What we see is theta, and after we get the interval of inequality of theta, that is what we need. That is the confidence interval of theta. Okay, these are the solution of the question 1. What we need to do is to construct the appropriate statistic based on sample data to estimate unknown parameters, and we need to apply some properties of normal distribution. Also, we need to understand the concept of confidence interval and know how to construct confidence interval. Okay, this is the question 1. Let's look at the question 2. This question is about likelihood function and MLE, and also the estimate of the unknown parameter. And accept this. What we need to do in this question is know how to understand the Bernoulli distribution. So let's look at the part A. In this part, we need to find the likelihood function and calculate the MLE. Before all of this, what we need to do is to understand the distribution of y. We need to find y follows the Bernoulli distribution because the probability because the possible outcome of this is only 2. Y is equal to 1 or y is equal to minus 1. So yi follows the Bernoulli distribution. So by after finding the size of the sample space, n is equal to 10, we can construct the likelihood function from the properties of Bernoulli distribution, and then we can apply ln to the likelihood function to calculate the MLE. We derivative the ln likelihood function and let it to be 0, and that theta is what we need, and it is the MLE of theta. Okay, this is the part A, and what we need to do in part B is to relate theta and normal distribution and transform normal distribution to standard normal distribution and then to solve for mu. Okay, the first three lines is about the transformation between normal distribution and the standard normal distribution, and then we need to use the the cumulative function and what we get from the part A, and also use the standard normal table to get this mu. Okay, to solve this question, we need to understand the concept of the Bernoulli distribution. Also, we need to understand the definition and the construction method of likelihood function. And also, we need to applicate the principle and the calculation steps of maximum likelihood estimation, that is MLE. Okay, let's look at the last question. In this question, it is a little complicated, but let's look at the part C and part D. We find that it is the application about the question 1 to construct the confidence interval and to do some comment about this interval guess. Okay, so in this question we need to do some calculation of expectation and variance, and then to prove the convergence in probability, and lastly we also need to use some knowledge about center limit theorem. There are 4 parts in question 3. Third part and the last part is about confidence interval, I just said, and the first part is about the mean and variance, and the second part is about proving. Okay, let's look at the first part. This part is very easy because we can just use the function I put on the left to do this part. And after doing this part, let's see what we need to do in the part B. In this part, we need to use the law of large number and also the continuous mapping theorem. After using the law of large number, we get this convergence function, and we know that applying the continuous function in this convergence function, we can also get a convergence function. So we get GYN convergence to GC. That and after rewrite the YN and the C, we got what we need. Okay, this is part B. And for part C is something about confidence interval. We have already know how to do that. 6 steps. The first one is to make the to choose the estimator, and the second one is to find the sampling distribution, and then to select the confidence level, and then to guess the critical value, and then to find the margin error of theta. And after doing these 5 steps, we can construct the confidence interval. So so this part C is similar to the part B in question 1, we also need to use the method of delta method to apply a function in this one to get a variance of a function or a variance of a formula. After getting this confidence interval, let's go to the part D. In this part, we need to interpreting the confidence interval. We need to make the comments. So in this part, what we can do is to, from some aspect, the first one, the center, the second one, the margin of error, and the last one, we can see something about the precision of our estimate. When the precision is larger, we get the lower precision, and our precision. So we can make comments from these three aspects. After doing this question, I think all of the people need to know how to make the application of the formula for the expectation and the variance for discrete random variable. And also we need to understand some theories like LLN or the continuous mapping theorem. And last, we need to know something about central limit theorem to make the proving. Okay, also we need to know and to applicate the method of construct the confidence interval into different questions. Okay, that's all I want to say in this class. Bye. Thank you.